Welcome to Friday Fractions Part 4. By now you know what you're doing on this, don't you? So we'll just get started straight away. Friday Fractions Part 4. Question 1. 2/8 plus 5/8. Easy question to start with. Just a reminder that we don't add the denominators, do we? 2 plus 5 is 7 and we're dealing with eighths, so don't add the denominators. The denominator is 8, 7/8. Question 2. Add in fractions again, medium level I would say. 3/5, let's write that properly. 3/5 plus 1/10. You should look at this and see a problem. The problem is the denominators are not the same. So I have to make a change. I normally change what looks like the smallest denominator. It's not really. I want tenths on the bottom. Because if I have tenths on the bottom, it will be the same as the other denominator. So we doubled the 5 to get 10. So we double the 3 to get a 6. Times 2 on top, times 2 on bottom. Do the same to the bottom as you do to the top. Now we have an easy question. 6/10 plus 1/10 is 7/10. So in fractions, in plus and minus, it's all about turning a medium or a difficult question into an easy question. On to number 3. 3/4 plus 2/3. Hard level, I would say, for add-in fractions. Because I would like to change the 3 on the bottom into a 4 by maybe timesing it by 2 or 3. But it doesn't happen. If you times it by 2, it's 6. If you times it by 3, it's 9. You can't get it to be a 4. So when this happens, you have to change both. And if you want to know what to put on the bottom, you can multiply these denominators as a little trick. 4 times 3 is 12. So that means if we put twelfths on the bottom, this will work. So focus on one side at a time. So let's go to this side first. What do you do to the 4 to get to 12? 4, 8, 12. You times it by 3. So on the top, 3 times 3 as well. You times that by 3 as well, and you get 9. Now we can focus on the other side. What do you do to 3 to get to 12? There's no point looking at the tops because one of them is missing, isn't it? So you look at the bottoms. What do you do to 3 to get to 12? 3, 6, 9, 12. You times it by 4. So now we can just times the 2 on the top by 4 as well. And we get 8/12. Now we have an easy question. 9/12 plus 8/12 equals, 9 plus 8 is 17. 17/12. Now that can be simplified. It doesn't have to be in this case. Excuse me. 17/12. We've got a picture of this. See these green circles over here? That's 12/12 I've just coloured in, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12/12 makes one whole. One whole. But we've got more than 12/12. We've got 17/12. So let's get another. So we've got 12/12, 13, 14, 15, 16, 17/12 now I've coloured in, okay? So can you see that I've coloured in one whole circle and a bit more? 1 and a bit. So 1. And the bit is 1, 2, 3, 4, 5/12. So 17/12 equals 1 and 5/12. Let's go on to question 4. We're going to minus now, so we can pretty much practice the methods we've just been doing, but with minus. Easy one first. I always keep these easy things on. This is year 3 level work, to be honest. Question 4. You first learn this in year 3, but you still need it in the SATs. So it doesn't go away. You still need the knowledge. You'll still need it in year 10. You'd always need it when you're doing maths. So 6/9, take away 2/9 is 4/9. Make sure you don't take the denominators away. That was easy, number 4. Number 5 is much more difficult. You don't learn this till later in the junior school, a lot later, because it doesn't work when you first look at it. 4/7 minus 1. I don't even know how to say this. 1/21. It's not 1/21. 1/21. Easier to say 1/21 probably. It's not a fraction you normally have to say, is it? So the bottoms are not the same. I'll change what looks like the smallest bottom, even though it's not really. 7 needs to go to 21. 7, 14, 21. If you times it by 3, it goes to 21. So times 4 by 3 as well. 4 times 3 is 12. We had a medium question. We've turned it into an easy question. Make sure you do minus, of course. 12 minus 1 is 11. And we're dealing with what we might call 21sts. I'd have to look up the official name. when you have 21 as a denominator. So we get 11/21. Just thinking if that makes sense. Yeah. And we're on question 6. Question 6 is 3/5 minus 3/8. 3/5 minus 3/8. This is a hard level because 5 doesn't fit into 8. 5, 10, 15. There's no 8 in the 5 times table. This is where you have to change both. 5 times 8 is 40. That will tell us what to put on the bottom. This is very similar to question 3, isn't it? But it's minus. What do you do to 5 to get to 40? You times it by 8. What do you do to 3 to get to whatever it is? You times it by 8. It's 24. So the bottom's been times by 8 and so is the top. On the other side of the question, something completely different is going to happen. What happens to 8 to get to 40? 8 and 16, 24 and 32, 40. You times it by 5. So times the top by 5. Okay, now we have an easy-ish question really. 24 take away 15 is 9, isn't it? 9/40 we get. That's plus and minus done. I always find it a little bit of a relief when we get onto times, because times is so nice and easy. Do you remember the rule for times when you multiply fractions? You don't have to change the bottoms. They're not the same, are they? And that's normally a big problem on plus and minus. But on times, it's no problem. 1 times 1 on the top is 1. 4 times 7 on the bottom is 28. Don't have to change the denominators when you do times. Let's clear that. Make sure you've got that one down. I hope you are recording everything I'm recording and not just watching. It's far better if you record it. And if you're really brilliant on this, you could do it ahead of me and just watch me afterwards, or just look at the answers. But these are not easy questions for many year 6, especially towards the end. So hopefully you're watching what I'm doing, recording what I'm doing. That will really help you to remember it. So number 8 is 4 times 2/9. I'm going to change the whole number 4 into a fraction because it's 4 ones, isn't it? It's 4 whole ones. I'm going to do that so that I can just times the tops and times the bottoms. 4 times 2 is 8. 1 times 9 is 9. 8/9. Can't simplify 8/9. You don't have to anyway in this case. That's question 8 done. And question 9 is next. 3/4 times 160. If you prefer, you could do 3/4 of 160 because, of course, of means times. But in this case, I'm going to do times. So I've got a fraction and I've got a whole number. That's not really easy to use my method, so I'm going to change the whole number into a fraction. I put in a 1 underneath, 161s. Okay? Then I've got to do 3 times 160. Now that is not easy for most people, so I'm going to quickly jot down a little method. I'd love it if you got used to jotting down little times and divides methods where you need them. Much better than sitting there for ages trying to do it in your head if you can't. If you can do it in your head, fine. But it's not something you have to be able to do. Anyway, 3 times 160 is 480. And the denominator is 4 times 1 is 4. Now that's a massively top-heavy fraction, isn't it? Look how heavy the top is compared to the bottom. So you've got to divide it. Remember that line means divide in the fractions. So you've got to do 480 divided by 4. Bus stop will do this for you really easy. It's a bit like 48 divided by 4, which is 12, but with a 0 on the end. It's 120. So you do have to simplify 480 quarters. It becomes 120 whole ones. And that's our answer to question 9. On to division. I know lots of people who have division as their favourite because they just love the KCF. They just love doing the keep, change, flip thing. So that's the method for this. 1/5 divided by 1/4. We couldn't do this. It's too hard, so we change it to times with the keep, change, and flip. Never flip anything except divide. So we've done all that. Now it's easy. 1 times 4 is 4. 5 times 1 is 5. We get 4/5. Divide does strange things when you divide by something that's less than 1. It actually makes things bigger instead of smaller. Anyway, question 11. It's pretty much the same method for question 11 and question 12 that we've just done, with just using our little trick first. 6/11 divided by 5 is a bit awkward because one's a fraction and one's a whole number. So you do this, don't you? 5 whole ones. Then you can do your keep, change, flip. Keep, change, flip. I feel like I'm talking faster on this video now because you're in the fourth part. You're probably much more used to what we're doing each time. So 6/55 we get. 6/55. On to question 12. Let's clear that. Question 12. What have we got here? 24 whole ones divided by 1/5. Now I have no idea what this is. Do I? I wonder if I could guess. Is it 120? I don't know. I don't actually know. We'll see. So 24 over 1. That's what we do to make a 24 whole ones, which is a fraction. 25 over 1. Keep, change, and flip. 24 times 5. That is 120, but we're not finished yet. 24 times 5. Yeah, is 120. Don't be scared to do the methods. They can be super quick. You can do that in 5 seconds when you've had a lot of practice. 1 times 1 is 1, so it's 120 whole ones, which is of course 120. So I didn't know I'd be able to do that in my head. I think I'm learning things as I go along. I thought it might be 120. I'm kind of getting a feel for what these things might be now. Question 13 next. What are we doing here? Oh, we've got a nice break for a nice easy question. 7 plus 2/5. You just literally have to put them together. 7 and 2/5 is of course 7 and 2/5. Easy, but I'm keeping it in. Only takes 5 seconds to do, doesn't it? Question 14. You've got to be able to do easy stuff accurately. And hard stuff, hopefully. 8 minus 1/8 is next. 8 minus 1/8. Now this doesn't work because the first number, 8, is a whole number. The second number is a fraction. 8 is much bigger than 1/8, isn't it? 8 whole ones, much bigger than just a little bit of 1/8. So there's different ways to do this. One way is change 8 into a fraction. And I don't mean 8 whole ones because with it being minus, the denominators have to be the same. You could do that and you would be able to get there by doing some more steps. But I'm going to change 8 into eighths, which are much smaller. So how many eighths in 1 whole one is 8? In 2 whole ones is 16, 3 whole ones 24, 4 whole ones 32, 5 whole ones 40, 6 whole ones 48, 7 whole ones 56, 8 whole ones 64 eighths. 8 whole ones is 64 eighths. You can get that just by singing your 8 times table. Up to 8, you'd get 64. So 8 whole ones is 64 eighths. Now we have 64 eighths, take away 1/8, and that will all work. Like I say, it's not the only way to do this question. I don't know why I did all this right down the bottom of my squares, but anyway, 63 eighths, not the only way to do this, but it's a way to do it. That answer is fine. Top heavy fraction. You could change the answer into a mixed number. I'll see how many eighths I can get in 63. 8 and 16, 24 and 32, 40, 48 and 56. 7 whole ones, I count on my fingers. I got up to 56 eighths. There's a few more eighths left, isn't there? Because there's 63. There's actually 7 eighths left. So the other answer is 7 and 7 eighths. Already on question 15. Simplify a very top-heavy fraction, 30/5. How many times does 5 fit into 30? Because we've got a lot of fifths here. You only need 5/5 to have a whole one. So we've got lots of whole ones. 5, 10, 15, 20, 25, 30. I counted on my fingers and my finger said 6. 30/5 is 6 whole ones. And as usual, very similar question, 31/5. What's 31/5? 5, 10, 15, 20, 25, 30. 6 whole ones, but only saying up to 30. That says 31. So I have 1 left. 1 what? 1/5, of course. 6 and 1/5. You can see the connection between those two questions, can't you? Let's go on to 17. 2/3 of 9,000. Now, as you know, of means times. So you could do of, or if you prefer, you could do times. I'm going to do of in this case. 2/3 of 9,000. Now, how I would do this is I divide by the bottom and times by the top. So I start off doing 9,000 divided by 3. And if you don't know what that is, a little bus stop will do it very easily. It turns out to be 3,000. So I divided by the bottom and I'm on 3,000. I've got to times that by the top. 3,000 times 2 is what I've got to do. 3 times 2 is 6, place 3 zeros. It's 6,000. The answer is 6,000. 2/3 of 9,000 is 6,000. Just in case you want to know, 1/3 would be 3,000. 2/3 would be 6,000. 3/3, the whole thing, would be 9,000. Question 18, right, the last 4 hardest fractions questions, I think, in the SATs. Quite a few problems in these, so there's different ways of doing them, like I always say. Just if you do it different to me and you get the answer, that's fine. Sometimes I even choose different methods depending on what the exact question says and what's going to be a bit easier. But anyway, I have a lot of problems in this. One problem I notice is that this one's in quarters and this one's in eighths. So I want to change this one here to be in eighths. So I'm dealing with the fractions first. 4 times 2 is 8, so 3 times 2 is 6. That's better because I have 2 and 6/8 and 1 and 7/8. Now I could add the big numbers. 2 plus 1 is 3. I could add the eighths. 6/8 plus 7/8. 6 plus 7 is 13. And I have this. But this is a famous one in the SATs, really, which they will mark wrong. It's not really wrong. It actually is. It is correct. It's just they don't like it if you have a mixed number. This is a mixed number, isn't it? Whole number with a top-heavy fraction. But they don't like a whole number with a top-heavy fraction. They don't mind it if it's not top-heavy. They don't like it if it's top-heavy with a mixed number. So that means these 13/8, I'm going to use 8 of them to get up to another whole one. And that will leave me 5 of them left. These are the toughest questions, right? So if you're unsure of these, just keep them working with me each time will help you. Not easy, I would say. 4 and 5/8 is our answer. Question 19. 8 1/3. This is really quite tricky, this is. 8 1/3 take away 6 and 5/9. First problem is the fractions having different denominators. I can sort that out quite easily. We've done a lot of this now. Times them both by 3, okay? Now at least we've got 9ths as denominators for both. I can do 8 take away 6 equals 2. But then I've got 3/9 take away 5/9, and you can't do that. It's 3/9 take away 5/9. It's not 5/9 take away 3/9. So it's not 2/9, okay? You've got the smallest number at the front, which doesn't work. So which means this does not work. A lot of people would put 2 and 2/9, but it'd be wrong. So in this situation, I think, I'll just change everything to 9ths. So the 8 and 3/9, I'm going to change into just 9ths. How many 9ths in 8 whole ones? 9 times 8 is 72, and there's 3 more there. So crazy, but 75/9 is what I'm going to change this whole side into. 75/9. I'm writing it underneath because I've got no room up the top. I'm going to change all this one into 9ths as well. 6 times 9 is 54, so there's 54/9 in there, plus another 5 is 59/9. At least I've got something I can do now. 59/9 is 16/9. 16/9 is the answer. Difficult, I'm not saying that's easy, but keep practicing, okay? 16/9 can be changed into a mixed number. 9/9 gives you a whole one, and you would have 7 more 9ths left. So 2 answers really. They'd both be acceptable for this one at the moment, the way they mark the SATs at the moment. And then we'll be moving on to question 20, won't we? Yeah, question 20. Oh, this is my Lego question. That's why I've got these little yellow Lego bricks. So question 20. I'll do it with the maths method first. 3 times 4 1/3. 3 lots of 4 1/3. So what I would do here is I would do times the big numbers. 3 times 4 is 12. Just noting that down, okay? It's not a question number, it's just me noting it down. So I did 3 times 4, that was 12. Then I've just got to do 3 times a third. 3 times a third. To do 3 times a third, you can do 3 whole ones times a third, and you get 3 thirds. Okay, so that's my second part of the answer, 3 thirds. Did you know 3 thirds is 1 whole? So we have 12 whole ones and 1 whole one. So the answer is 13 whole ones. That is the answer. They'd want you to put that as the whole number 13 for sure. The answer is 13. So let's show you that in Lego bricks, just to prove that it is 13. Let's write the question number back in case people are moving around the video so they know what one I'm doing. So question 20, 3 lots of 4 1/3. So I have 4 1/3 here. 1, 2, 3, 4 Lego bricks, and you know you get those little tiny ones, if you know Lego, you get those little flat bricks, which are a third. They're actually a third of a normal brick. So there's 4 1/3. Here is another 1, 2, 3, 4 1/3, and here is another 1, 2, 3, 4 1/3. That's our question, isn't it? 3 lots of, remember times means of, don't you? 3 lots of 4 1/3. So we're going to have 4 1/3 3 times. And we already found the answer using maths, and the answer was 13. So I'm just going to move them all into a tower and prove to you that we'll get 13. Sometimes the little stud on top of the brick doesn't fit perfectly. But you get the idea. If we're building this tower up, we use the whole bricks first, and we'll put the thirds on later. So using the whole bricks, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But if we use the thirds, I'll try and make these fit properly. Put that on top. Oh, not quite. Nearly. But you can see, I'd like to get that one looking a bit better. Hopefully you can see that makes, it's not real Lego, it's computer Lego. Can't get it to look perfect. But you can see that it makes an extra brick on top. That's the size of a brick, isn't it? That brick is the same as those 3 put together, the same length. So total we have 13, don't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the 3 thirds make 13. So the answer is definitely 13, proved with that big old tower. And we have one question to go, which is question 21. So let's destroy the tower. Good to knock it down, wouldn't it? Like this. Destroy the tower and go to question 21, which is 5 1/3 divided by 7. Too hard to do divide, so we'll change it to times. How shall I do this one? I'm going to make 7 7 whole ones, and then I'm going to change this mixed number into just a fraction. So we'll change it to thirds. Lots of thirds in 5 whole ones. 3, 6, 9, 12, and 15. Plus this one is 16. So change that to 16 thirds. I'll write it underneath if I don't have space. That's 16 thirds. Let's just copy the rest. Divided by 7 over 1. Now we're in this situation with fraction divided by fraction. We can just do our keep, change, flip, which lots of you really like. Keep, change, and flip. 16 times 1 is 16, and 3 times 7 is 21. 16 out of 21, 16 over 21, 16 21sts, if that's how you say it. And we're done. Question 21, 16 21st. So you can check all of your answers. I think on last week, one of the answers on the pink boxes was incorrect. Did the question right during the video, otherwise I'll do the video again, but one of the answers was incorrect, so check carefully. If anything is ever incorrect on the pink boxes, I'll always write it in the description of the video. So thanks for listening. We're getting faster every time, I think, and I'll see you next time on Friday Fractions, won't I?